We'll see graphs like this again later in a slightly different context. But time series graphs are basically what we're doing is displaying data that is changing over time. So typically what we're doing is we're looking at some sort of characteristic of some sort of variable that changes as time progresses or as time moves on. Some examples of things like that you'll see are things like average yearly temperature. Okay? If you were to measure the average yearly temperature in a specific location, what you'll notice is that as time progresses, that average yearly temperature is going to fluctuate. Other things that you can do in the same vein are looking at the Olympic winning time in the mile, inflation, and world populations. These are all things that you can display using a time series graph. And the pictures that I have over here are two examples of time series graphs. The top one here is something that would be reminiscent of Olympic winning times in a mile, and the bottom one here is something along the lines of the average yearly temperature. Now, when you look at these graphs, what kind of things draw your attention? What do you see when you look at these graphs? In the first one here at the top, what do you notice about the data that you're collecting? Okay. What you should analyze or what you should see in this is that there is an overall trend to how the data is progressing as we move through the year. And in this case, what we're looking at a sort of an overall downward trend to our data. And when we're looking at time series graphs, that's what we want to look for. We want to look for what kind of trends are there in the data. Right? Sometimes you're not necessarily going to see an easy trend, or there's not going to be some sort of obvious trend that you can extrapolate from that data. Right? As we look at the second set of data here, in this particular example, what do you notice about that particular set of data? Is there a trend that you can identify?
It's like generally getting fired.
You need to find the average.
When finding that, well, we need to be a little careful with, again, using terms like the average is a troublesome thing sometimes. When we look at this data, and we'll find other ways of analyzing this data later on as we move through the course. When you say the average of the temperatures, yeah, we can find the average of the temperature. What is that going to tell us necessarily though about the overall progression of the data as we move forward, right? If we're only looking at the average of this data, that's going to tell us a single number. Right? Is there some way I can utilize this data to maybe make a guess about what I think the temperature is going to be in the future? Is there something about the shape of this data or the trend of this data that I can use to make that guess? If I was to just look at the average, that average is not going to give me a good way of estimating sort of what the temperature may be 5 or 10 years into the future. Okay? So finding the average is an important aspect of working with data, but it doesn't always necessarily tell us everything we need to know. All right? This data here, if you look at it, it's kind of all over the place, but you can maybe make out a slight upward trend to this data, a very slight upward trend to this data. And again, as I said, we'll find ways of looking at this data in another context later on, but there is sort of a slight upward trend that we get from this data. Okay? Time series graphs are important because they allow us, hopefully, to make extrapolations about what we think future values are going to be based on this previous data that we collected. Okay? And that's what time series graphs are good for. Okay. All right. So that's all of the graphical displays that we're going to work with right now. The next thing we're going to do is we're going to work with the numerical summaries. We've looked at graphical summaries of data now. The next thing we can utilize is numerical summaries. Okay? Now, when we talked about looking at data, a couple of things, when we talked about looking at graphs, a couple of things came up. Remember when we were looking at quantitative data graphs, we were interested in three major things. We were interested in the shape, we were interested in the patterns, and we were interested in the shape, pattern, what was the third one? Something else I think this. What was it? user responses, gaps in the data.
High points.
High points, okay, so the modes and things like that. So, right, those are the main things we look at. The numerical summaries we're going to talk about sort of highlight some of those aspects. And the first question that we can ask about numerical data is, what is a representative observation like? I'm going to give you some data up here, and I want you to take a moment and sort of look at your data, the stuff that I put up here, and tell me what you think a representative observation would be. First examples here. Salaries. And here are the salaries that we have. 10,000, 11,000, 15,000, 13,000, 150,000. That's our first one. Our second example. This is number of times married for men and women. Zero. 5,000. 161. 4. 3. 1. 5. All right. So here are two examples of some data that were collected, and what we're interested in, if we're interested in describing what an observation that sort of basically is descripting or representative of all of the data that is given. Okay? Find something that best describes all of the data given. Okay? So, when we look at that first collection of data there, what would a representative observation look like? If I was to close my eyes and someone was to pick someone out or pick a value out at random and say, this value represents these numbers accurately, what would that number be? How could I find a numerical value that sort of describes a typical answer or a typical value in this top group here? How could I find that?
You can find the mean.
Okay, so if we found the mean of these values, what would that mean be?
23.
Is it 23? Should be bigger than that. What's the mean of those 5 numbers?
199 divided by 5.
39.8. So the average here, the mean value, is 139.8. Now, let me ask you, does that 39.8, does that accurately describe most of this data? I mean, is that a representative value of these 5 numbers?
No.
Not really, right? That 39.8 is considerably larger than more than half of those values, right? Okay? So that's not really representative of my sample. What's another way, or another value?
Median.
Okay, let's try something called the median. Median value here would be what?
13.
Okay. Median value here again, the median, if you'll recall, is the value we get when we order the numbers from least to greatest and take the one in the very middle. In this case, the median is the 13. Now, is this value more representative than the first one? It's closer. Notice the 13 sort of is very close to the 4 small numbers. Granted, there's this one really, really big number that sort of throws everything off, but the 13, for the most part, describes most of this data pretty good. Okay? It's pretty close to the majority of our data here. Right? So in this instance, this would probably be a value that we would say is representative of this data. Okay? All right. What about here at the bottom? Here at the bottom, there's two collections of data here that we're actually working with: data for men and data for women. If we were to just focus on the data for men, for example, what would be a representative value for number of times a man was married? What would be a good choice for a representative value in this case? Would it be good to use the median in this case? If we're looking at the number of times a man was married, if we were to take the median there, what would the median be?
Oh, we're talking about
Median times married for men. If you were to look, remember each one of these numbers here represents number of times married in the left column. So there are 5,861 men in this sample that were never married. 2,723 men who were married one time. Excuse me. And then 105 men who were married 2 times. Now, if I was to order those, if I was to write out all of those values, I would write 0, 5,861 times, 1, 2,723 times, and 2, 105 times. What number would be in the exact middle?
0.
The 0 would be, right?
Yeah.
The number, yeah, the zeros in this case would be where the median lies. So median times married for this particular collection of data would be 0. Okay, well, there were lots of men that were married though. Does this 0, is this a good representation for this data? Granted, 5,000 men were never married, but there were a bunch of people that were married. And this 0 does not, sort of take that into account. Okay? So the median here would probably not be a very good way of describing a typical representative of this collection of data. Okay? What about the mean here? The mean for the number of times a man was married. Do this real quick. 27, 23. 7, 23. 5. A little over a third. 3, 8. Okay. Now, again, you sort of have to look at this and you say, okay, what does it mean to be married 1/3 of the time? Well, it means like you marry Britney Spears for an hour and then you get divorced. So, but this value here, this value sort of does give us an indication that the majority of the people in our sample were not married. But there were some people that were married at least one time. Okay? Interpreting how to read this data, interpreting how to consider what each of these values means. It's an important tool that we need to develop in order to really understand when people present us with numerical summaries like this, what do they mean? Okay? The mean of 0.338 here means that the largest portion of our data were not married at all, but there was about a third of the time someone was married at least once. Okay? That's one way that you can interpret these values. Now, these two numbers, the mean and the median here, are what are called measures of center. Okay? They describe sort of the center point, or the representative observations from a collection of data. Now, they're also used in lots of different ways. And being able to identify when to use which one and which one's better for the data you have is a skill that you want to try to cultivate and grow. Because if you're able to identify how to use data in ways that help you, then that makes you that much better of a skilled worker than people who are not able to understand these values. So, What is